Hello everyone and welcome back. So let's keep on doing examples. Working through these problems, practicing. So this is example 4.9, and how does it work? Well, we got a truss and we want to compute the reactions. Luckily we don't care about anything on the internal forces, none of those matter. All we care about is our reaction forces right now. We're just mastering that skill. Now, unlike the past few times, we've got a force at an angle. Terror of terrors. And so we're going to have to figure out how to deal with that. Spoiler alert, it's not that hard. So what are our steps for analysis? Well, what do you think it's going to be? It's going to be draw free by a diagram. So I've got force up right here, force up, and to the right here. Second, get my equations of equilibrium. I'll probably pick a point. I like that point to do my sum of moments round. And then use everything else to solve for the unknown forces. Okay, so first off, let's draw that free by a diagram. So I get rid of my roller and my pin support. I draw my arrows. I also take this force that was at an angle and I go ahead and say, you know what? I'm going to break it up into its horizontal and vertical components. Now, if it looks weird to you that both of those are touching the same point, like you might be used to me like doing something like this. I can understand you just think that looks weird, but you know, it's the same exact thing. I can do it in any direction I want. And so since it makes a little more sense when I'm thinking about distances to have all the points acting at the same, location, I just forget about these two. Now, how do I break them up? Well, let me go ahead and try that. So I've got this one right here. And I have my horizontal component, that's 65 degrees. I know this is 1,000 pounds. So we name them. This will be adjacent. This will be hypotenuse. And adjacent over hypotenuse is what function? It's cosine. So cosine is 65 degrees. And if I solve that, well, I get that adjacent is equal to 1,000 cosine of 65 degrees. And that comes out to be 423 pounds. And as you might be able to guess, this is opposite over hypotenuse. And so for that one, I would simply change this. Instead of cosine, I'm going to use sine. Because it's opposite over hypotenuse. And I get that 1,000 sine of 65 is 906 pounds. Okay, everything's hunky-dory. So now, let's do my equation of equilibrium. So I'll probably go ahead and say, well, first off, are there any forces in the horizontal direction? There are. This time we can't just say that this is zero. Are there forces in the vertical direction? There are. And can we do some moments? We can. So let's solve for those unknown forces. First off, the easiest one. You can see that this one's going in the x direction and this one's going in the x direction. Or this one's going the horizontal direction and this one's going the horizontal direction. They're the only ones around. So if I write them, I'm going to make right to the positive. Now it's equal to 0, and therefore they have to equal each other. Simple, very simple algebra. So I get the first one. And that worked wonderfully. Now I've got two reaction forces left, and I gotta solve for them. So let's see, what's gonna be next? Well, I can take this sum of the moments about any point I want. I could have done it around B, I can do it around A. I can even, if I wish, do it around this point right here. It doesn't actually matter where you take your moment around. It will work regardless, as long as you're careful. Now here's the thing that is slightly difficult to realize. So I want to start drawing my little arrows, okay? I'm doing it around this point, so up and down, okay? That's one, up and down. That's two, over here. That one does one as well. And then here's where you're probably going to get confused. Okay? Do you notice this one? That one causes a moment as well. If you're trying to figure out what direction it goes, it's not nearly as easy this time. Okay, it's not nearly as easy this time. The biggest thing is just draw a line straight over, okay? Draw a line straight over from that force, and then go up, and then go over with it. So if we look at this, which one's going counterclockwise? Like that positive, that one's counterclockwise, that one's counterclockwise, and these two are clockwise, they'll be negative. So for any of these ones that you can't use this method, if you're using this method to help yourself, just draw the line of action of the force that's got you confused, both directions to infinity, and then you just drag your little arrow line straight over to it, and then turn along with it in the same direction that the force is going. Okay, ugh, so much to erase. All this erasing. So I do that. I have my vertical one times 80. Makes sense. It's 80 feet away. I have 3,000 times 40. It's negative because it's going the opposite direction. I've got 906 times 60 because it's going the opposite direction. Yep. And then I have this component right here. That's this horizontal component, which is causing a moment as well. And so I multiply all those together, and I get that RBV is 2,100 pounds. Now also look at this right here. This is the distance to the line of action of this force, the perpendicular distance. So if you're confused about what that is, just draw the line of action from one side to the other, all the way around, and then draw a right angle from your force straight to that line. Okay, here we go. This is right here. This is my perpendicular distance. And what is that? It's going to be 15. It's the same as that over there. That will help you. Just make visualization a little bit easier. Okay, and then finally I have my forces in the vertical direction. So by this point I've solved for pretty much everything. And so I know what RBV is. That's going to be the 2,100 pounds. I know everything else, so I just have to add them all together. So this is positive, positive, negative, negative. Okay, so RA plus 2,100 minus 906 minus 3,000, and that should equal 0. So what does RA come out to be? Well, it comes out to be 1,800 pounds. Now, I'll go ahead and tell you this. If you are in a problem and the algebra seems really, really, really hard, like you're trying to solve it and you can't figure out a way to solve it, you probably have made it too difficult on yourself. There's probably another step you could have done first, which would make things easier. So if it seems really, really difficult, like you're getting like a system of 3 equations you have to solve at once, that's probably too hard for this class. It means you probably are making it overly difficult. Try a different equation of equilibrium. Remember, you got 3, and there's no specific order about which one you have to do first. So if you try that one and that's hard, forget about it. Try this one first. Still too hard? Forget about it. Try this one first. And you can just go from there. So, thanks for listening, and I'll see you all next time.